Communications. It's tough up here for cellular, so we're using satellite internet. Thanks, Elon. Starlink works fantastic. Still not completely built out, but for what we're dealing with here in the middle of the woods, we're getting revolutionary speed, and we need that because not only do our guys need to talk, but all of our equipment needs to talk to each other, and that's pretty tough to do when you're at 10,000 feet in the mountain. So that's a huge leap forward for us, and extremely reliable. Next up is power. Our power requirements are pretty large. Not only do we need to be able to charge all of our field gear from GPS handheld receivers and radios to our laptops to communicate with the office at night, and just basic cooking and refrigeration needs, so the guys are relatively comfortable, and we do that as environmentally responsibly as we can. And today that means lithium power stations. The technology's come a long way. It's still quite a bit more expensive than running diesel generators, but it's zero impact on the environment. It's rechargeable and sustainable through solar panels, and we're running about 7,200 watt hours with two devices that fit in the back of a pickup truck that give us all the power we need while we're on site. And that's important when you're running something like ground penetrating radar, because all that gear needs to be charged up every day. So speaking of ground penetrating radar, let me get to what you've been waiting for, which is how the technology works and how we run it in the field. In its simplest form, it's simply a radar device that transmits a radar signal through the front antenna, and as you move forward at the proper speed, it'll pick up that bounce or that return signal, and using a very simple calculation, a time distance of arrival algorithm, it'll actually show you with amazing clarity what is underground. In simplest form, we run a 2D model, which is basically running straight lines until we find an anomaly or a reading that looks different. And sometimes that can be a heavily iron laden stone, or it can be a tunnel from previous mine workings. And once we find something, we'll come back and lay out a grid pattern, usually a 1,000 feet in length and probably 750 feet in width. And then we do what's called mowing the lawn. And it sounds like simple to do, and if it was a flat lawn it would be, but in this type of environment where we're heavily forested and you've got everything from trees and down trees to stumps to boulders on the ground, it's not as easy as it sounds. So we spend a fair amount of time marking the territory with everything from flags to stakes to string lines, because it's pretty difficult to start at point A and keep a straight line when you can't see point B, your destination, because of basically the forest in front of you. So the goal is to run out that 1,000 foot, take a step 2.5, 3 feet to the side, run back 1,000 foot, take another step, run 1,000 foot back out, and a sort of a zigzag pattern that looks like mowing the lawn, because in the end we'll cover that whole grid saturated with that radar signal, and then the computer then takes over and it will tell you, it'll literally show you with amazing accuracy what is underground. And years ago they came up with this technology for things like buried utilities, but today the technology is so advanced that we can see things that we've never been able to see before. So keep your fingers crossed, stay tuned, we'll keep you posted.